number for K. It's 101.06. If the reaction has the concentrations, it's shown which way does it go. Now notice, sometimes I see these, and people do about 20 trials, and finally they get 5 right. If it takes you 20 trials to get 5 right, and there's only 2 possible answers, that means don't buy lotto tickets, and you're going to be terrible on the multiple choice when we get to the final exam. Okay, so you've got to work out what's happening. So you've got to write the equilibrium expression. It's going to be this number divided by this number squared divided by that number. And then you have to compare it to this number, see whether it's bigger or smaller, and then you put your mark down. Okay? So let me pull out the calculator. So this is not a really tough problem. It might be something you see on a multiple choice question on the final exam. But we have something like this as part of an equilibrium problem. So let me write down the reaction here the way your book does it. I'll read this so I can see it. These numbers that he gave you here are I talked about the ICE table. This is the initial concentrations. And so he said CO 0.258 molar. Notice he does things in molarities directly. H2 0.0553. And CH3OH 0.478. Here's the change. I call it delta. And the reaction is either going to go left or right to get the equilibrium. And I'm going to say X is the amount that it goes. So X, this is the change, which I call X because I don't know what it is. And the change is going to be, have the units, moles CO per liter, molarity. I'm going to put an X here. And I'm going to put a 1 to 2 mole ratio, so this is 2X, 1 to 1, 1X. Now the place where you use Q, if the reaction goes this way, then these decrease and this increases. If the reaction goes this way, these two increase, this one decreases. So you use the Q to decide what type of sign to put in front of these variables that represent the stoichiometric change. Okay. So I'm moving into the next problem already. Okay, so the first thing I have to do is calculate Q, the equilibrium expression, and you know, you can just write this. Q is equal to 0.478 over 0.258 times squared. Okay. And if you know, when you're first doing this, I always suggest you practice putting in all the words and all the letters, but eventually you just know where the numbers have to go and what the exponents are. Next thing to do is turn this thing on. Can't see? Gotta turn the light down. How's that? It says 605. I think I put it wrong parentheses. I'll just say 605. And now I have to go back to here. The K that he gave you was 1.06. So that means the numerator is too big, the denominator is too small. So this decreases because the reaction is going this way. These two increase. So the E line, the equilibrium, complete the solution, you'd say, but I'm going to get this the next time, so I'm just doing this because it's all here. Over times, oops, there's a plus sign here already. And the first thing I'll say is you won't get a problem like this to solve for one simple reason. If you look at the power of x, it's squared times x makes it a cubic equation. We don't go past quadratics in this equation. And if you have your fancy calculator like this, you can probably expand it out and enter all the multiple coefficients, and you say solve, and your calculator will solve it if you know how to do that on your calculator. Okay? But we're not going to do that because one of the things is for most of these for the exams, we're going to use a simpler version of the calculator. Or erase all your memories and then you won't remember how to do the solver anyhow. So that's for a different course. So we're not going to get anything higher order than squares. But this is how you would set the problem up. In other words, you put down your initial numbers, then you put an enter to change, and you call something x. If I would have called this x, what would this number be? 1/2, because it's a mole ratio of 1 to 2. And this is 1/2. Most of the time, people like small whole numbers rather than fractions, because you're putting it into cubes and squares and things. So you like small whole numbers, so you basically just pick numbers for the coefficients. So you pick whichever one is the lowest number. If this was a 2, 4, 5 or something, you'd say 2x, 4x, 5x, because that would be the ratio between them using the mole ratios. Okay? So this got a little ahead of the game. Doing the cube, all you're doing is plugging in the numbers, looking at that. Let's see if I calculate a cube correctly. Because which way did I say it goes? I said it goes to the left because Q was bigger than K. Let me check it. Left to right. I didn't get it right. Let's see what you got. You got 606 times 10 to the 2. I got 605. Oh, I pushed the wrong button. I said it was going this way, which is what? Looking at it this way, right to left, and I clicked on left to right. Okay, so you have to remember where your hands go. The joke I do in 1A, when you remember when you were in kindergarten, the teacher says, hold up your right hand, and you go. You're looking from side to side to see which hand to put up. You don't remember that when you're learning your right and left hands? No, well, I remember that, because I had a hard time with each hand.